All right, welcome to the section 1.3 lecture today. Today we're going to talk about adding and subtracting rational numbers. For our purposes today, we're going to think that rational numbers are all fractions and then all decimals that either end or repeat forever. Okay, that they have some kind of repeating pattern that will eventually end. Most of the time when we're talking about adding and subtracting, I'm usually talking about ending decimals, but it could be the case that we have a decimal that repeats the same number forever, and we would want to talk about how to add or subtract that. So when we're looking at decimals, the big thing to think about is that we can stack them and add or subtract them. So I can go like 2.48 plus 5.34. I can stack them and add or subtract them, but the key here, and it doesn't really show up in this one, it shows up more in this one. I would not want to say 5.748 and 3.2. Okay, that's actually incorrect. What I would want to do is I wish that would have worked. I would actually want to stack the decimal point, the decimal point. Okay, so stack the decimal. And then add or subtract. The other thing I'm going to tell you, since with dealing with decimals, a pretty common thing that I'll recommend is to use a calculator. And I know that seems weird coming out of a math teacher's mouth, but I'm more of a realist. Calculator, sorry, I was trying to write and spell at the same time. I'm more of a realist and know that if a calculator is available, we're probably going to use it if it helps us. And calculators are built in a decimal foundation. So, I mean, even if you try to, on most calculators, if you try to type in a fraction, it's going to give you a decimal response. So why not use that to our advantage? Why not use decimals when we can? And I'm not saying that given any problem, turn it into a decimal, figure out the answer, then try to turn it back into a fraction. That's not what I think of. Kind of with the entire theme of this section and with later sections as well, if the problem starts with decimals, answer in decimals. If it starts with fractions, answer with fractions. They should work out pretty nicely to make that doable. Okay. So, and like I said, use a calculator. That's what calculators are meant for. They're meant for, sorry about that. They're meant for decimals, so use it. If I've got 2.48 plus 5.34, I can just as easily use a calculator to tell me that is 7.82. And sure, I could have added them without the use of a calculator. That would have been just fine. That would be 8.948. Okay, but if I need to, use a calculator. That one we get 4.114. And on the last one, we get 7.0552. Okay. And in most of these, when they have an ending decimal, I do want to see all values of that ending decimal in that answer. Okay. So that's about it for decimals. Let's talk about fractions, because especially on a standard calculator, I don't have any way to deal with fractions. As I said earlier, I could turn fractions into decimals and do it that way, but That's not what I'm into teaching. We're talking about fractions here, so we know that our answer needs to be in fractions. And the big key with adding and subtracting fractions is that we need a common denominator. Okay? The denominator being the bottom number in a fraction, we need those to be the same number. Okay? Like in this one, I have 6 and 6. A very common unwritten step at this point is to combine this problem into being the 5 plus 5 in the numerator and the denominator being that common denominator that we found, or in this case we were given. And so then I would add 10, and it's 10 over 6. Now, the only thing I would do here is to simplify it. They're both multiples of 2, so I can divide both the top and bottom by 2 and get 5/3. I would not, on the other hand, turn it into a mixed number, as I know some of you might be inclined to do. I'm okay with improper fractions. Okay, they're more useful in later times of math that I would just say leave it as such. And the second one here, I don't have a common denominator, so I want to figure out what I can turn both 2 and 8 into using multiplication. And I think I can turn a 2 into an 8. So I'm going to leave the second one as 8, or as 5/8, I should say. And I'm going to turn this 2 into an 8. Well, how do I do that? I do that by multiplying by 4. And whatever I do to the bottom, I have to do to the top. So 1 times 4 is 4. And if we think about that unwritten step, usually that middle step, it would be 4 plus 5 over 8, which in our case is going to be 9 over 8. Okay. If you want to write that step in the middle, that's totally fine. It's up to you. Pretty similar on the next one. I have a 4 and an 8. I think I'm going to turn them both into 8s. This one's a subtraction problem, so it's a little bit different. But in order to turn 4 into 8, I multiply by 2. So I'll do that to the top, multiply it by 2. 6 over 8, and that one's the same number, 5 over 8. 6 minus 5 is going to give me 1, and so we get 1 over 8. The last one, there's pretty tough to find a multiple of 5 that's also a multiple of 12, unless you multiply them together. 5 times 12 ends up being 60. And so I'll use 60 as my common denominator. So how do I turn 5 into 60? I multiply by 12. So I'll have to do the same thing to the top. 4 times 12 is 48. And for this one, how do I turn 12 into 60? I multiply by 5. So multiply 11 by 5, and I get 55. And then when I do the subtraction, I'm going to have 48 minus 55. 55 is bigger, so this is going to be a negative. And I believe it's going to be a negative 7. And just so we know, since 7 is not a multiple of 60, these two can't be reduced since 7 is a prime number. Let's talk about how to turn mixed numbers into improper fractions, because again, I said I'm totally fine with with improper fractions, and I actually dislike mixed numbers. Okay? When I'm looking at a mixed number and I want to turn it into an improper fraction, that means that I have some number out in front, some whole number part, and a fractional part. Okay? So I have a whole number part and a fraction part. And what I want to do is I want to take the denominator and I want to multiply it by the whole number, and then take that result and and add it to the numerator. So I'm thinking, now this is all work for the numerator. The denominator stays the same. The numerator is going to be, what did I do? I went 4 times 2 plus 3. 4 times 2 is 8, plus 3 is 11. So I would get 11 over 4. And I don't usually write this. Okay, I usually do it in my head. So let's look at that. Look at a couple examples. I multiply. 2 times 5 is 10. Plus 1 is 11. So I have 11 on top. Denominator stays the same. When I have a negative, I don't want to think about the negative. I just rewrite the negative. And now I think of this as, well, I know it's going to be over 7, but it's 7 times 7, which is 49, plus 4 is 53. Okay, notice I didn't say 7 times negative 7 would be negative 49. Negative 49 plus 4 would be negative 45. I didn't say 45 over 7 or negative 45 over 7. Okay, I forgot about the negative for a second. That's okay. That's what I want you to do. I want you to just say, okay, it's negative. All right, it's negative. It's over 3. All right, it's over 3. Now forget about that negative. Say 3 times 3 is 9, plus 2 is 11. And then on this last one, it's a positive. It's over 8. I can put it over 8. 8 times 14 is 32, and 80 is 112. So that's 112. Plus 7 is 119. So this will be 119 over 8. And that's it. Okay. So when we move on and we deal with mixed numbers, and we add and subtract mixed numbers, I want to go from mixed numbers to improper. So mixed to improper. I need to find common denominators. And then we'll add or subtract. So let's take a look at how these are going to go. Mixed number turned into an improper fraction. It's going to be over 4. 4 times 1 is, 4 times 2 is 8, plus 1 is 9. Do that on the other one. It's going to be over 6. 6 times 1 is 6, plus 5 is 11. Okay, so now I have improper fractions. Now I need to find common denominators. I think I can turn both 6 and 4 into a 12. I think I can turn both those into 12s. I do that by multiplying 4 by 3, so 9 times 3 is 27. And 6 multiplies by 2 to give me 12. 11 times 2 is 22. And so we have both these over 12. 27 and 22 is going to be 49. So we have 49 over 12. Okay. And you can double check me, but I don't think that reduces. Next one, 1 3/4. So 4 times 1 is 4, plus 3 is 7, so 7/4. And then I'm going to turn this 4, or 4 over 1, into fourths at the same time. Right, so I want to make this a denominator of 4. And so I want to take this and make it a denominator of 4. So to do that, I have to multiply it by 4. 4 times 4 is 16. Okay, then we're adding these. 7 and 16 is 23. So that's 23 over 4. Okay. Next one, 1 4/5. That's going to turn into some number of fifths. 5 times 1 is 5, plus 4 is 9. This is going to turn into a number of halves. 3 times 2 is 6, plus 1 is 7. I think with 2 and 5, the best I can do is turn them both into tens. To do that, I'm multiplying 5 by 2. So 9 times 2 is 18. I multiply 2 by 5. So 7 times 5 is 35. And when I subtract those, I'm going to get a negative because the 35 is bigger. And it's going to be a negative 17 over 10. Pretty similar process on the next one. I want to turn it into an improper fraction. It's going to be a number of halves. 2 times 15 is 30, plus 1 is 31. So we have 31 there, and I want to turn this into a number of halves, and right now it's a number of ones. So to turn 1 into 2, I multiply by 2. So 3 times 2 is 6. So 31 halves minus 6 halves. 31 minus 6 is 25. Okay. And let's get these last 4 done. Okay, in fact, well, let me do the next one because it gets a little bit ugly. But then I'll have you pause and try to work on the last 3. Okay, so let's look at this one. This one like I said, it gets a little bit involved. Got to turn it into an improper fraction. 8 times 4 is 32, plus 7 is 39. 10 times 1 is 10, plus 7 is 17. And with an 8 and a 10, it's probably best to turn them into 40s. Okay, because 8 times 5 is 40, and 10 times 4 is 40. So let's turn them into 40s. Okay, so here I've got 39. I'm multiplying that by 5. I'm actually going to have to do that, I think. 45 and 15, 19, 195. And then 7, I have to turn 10s into 40s. So that's multiplying by 4. So 17 times 4. 28. And 40, so 68. And then I need 195 minus 68. Like I said, this one's a little bit tougher. That's going to turn into an 8. That'll be a 15. It looks like that's going to be a 3. No, not a 3. I think I said 3 earlier. That's a 7. That's going to be a 2, and that's going to be a 1. So 127. So 127 over 40. That's as good as I can do. Okay. 1 3/4 minus 1 1/2. There's probably a quicker way to do this, but to keep with our same strategy. Oh wait, I was going to have you pause. Go ahead and pause this and try these last 3 problems. See how you do. All right. I hope you paused it. I hope you worked those out. And now we can get to these. Okay. 4 times 1 is 4, plus 3 is 7. And then 2 times 1 is 2, plus 1 is 3. I'm going to turn these into fourths. Multiply it by 2, I get 6. 7 minus 6 is 1/4. And there we go. Last 2 here. I'm going to deal with the mixed number first, and then I'll deal with the whole number. 9 times 3 is 27, plus 4 is 31. I'm going to turn this into some number of ninths. And to do that, I need to multiply it by 9 because this was 5 over 1. So I'm multiplying it by 9 is going to give me 45 of them. And now we just need to add 45 and 31. That seems like 76. And there we go. Last one we have, yeah, we're topping that 20-minute mark. I'd try to keep them between 20 and 30 minutes. So let's see. This one, I'm going to employ the use of a calculator. We want 12 times 8 plus 11. So 107 twelfths. 12 times 9 plus 1 is 109 twelfths. I already have common denominators, so that's good. Just have to add these, and that's going to be 216 twelfths. Just to check. Yeah, 216 is a number of twelfths, so that makes sense that it's going to actually equal 18. Okay. They're both multiples of 12. You can divide them both by 12 and get 18 over 1. That being said, if you have any questions, make sure you write those down and ask them in class. Otherwise, have a good day, and we will see you in class.